Good day, students. On this group, we're going to be going over some questions to get you prepared for the midterm exam. So, write down the title of this lesson, um, midterm, midterm review session 2, review session 2. Okay, let's take a look at the first example, number 1. What is y if 2 to the 2y plus 1 equals 16? Okay, so anytime you want to eliminate bases like this, what you have to do is you have to make sure the bases are the same. Okay, so this is 2. The question is, can I express 16 as a power of 2 and then eliminate them by taking logarithms base 2? Of course, let's see, 2 to the 1 is 2, 2 to the second power is 4, 2 to the third power is 8, 2 to the fourth power is what? 16, right? So we can rewrite this as 2 to the fourth. So we write this as 2 to the 2I plus 1 equals 2 to the fourth. Now I can eliminate these two 2's by using logarithms. So I'm going to take log base 2 on both sides. Log base 2 of 2 to the 2y plus 1. And on the right side, log base 2 of 2 to the fourth. Okay? Now, since the base and the logs match, they cancel out, and then the log, these two cancel out. So you're going to end up with 2y plus 1 equals 4. Okay? Now, this is a simple algebraic equation, algebra 1 equation that we can solve. Subtract 1 divided both sides by 2, and we're done. Alright? So subtract 1, 2y equals 3, divide by 2. We have y equals 3 over 2, and that's your final answer. Okay? So this is what satisfies that original equation. Alright, let's move along to number 2. Number 2, it says solve log base 27 of 3 equals x. Okay? And we have some options here. Is it 1 over 9? Is it 1/3? Is it 9? Or is it 3? These are the options that we have. Alright, so which of these can satisfy this equation? So let's go ahead and solve this. So how do we do this? Log base 27 of 3 equals x. If we knew what power to raise 3 to, if you knew 27 to what power basically gives you 3, if we knew what that is, then we could put it here and simplify. But let's assume we don't know what it is. So I'm going to use this base. I'm going to put big 27 on both sides. So put a big 27 here and put a big 27 here because the bases are 27, right? So put 27 and 27 here. And then you're going to have log base 27 of 3. And then you have x here. Exponentially, both sides using 27 as the base. So the left side is 27 and the log cancels out. So you're going to have 3 equals 27 to the x. Alright? So which of these can I plug in into this power right here to get 27? If I can plug in the correct one, then I'll get the answer, right? So I can plug and check. So I know that if I plug in an integer, like 9 or 3, it's going to make this bigger. I want something that's less. So it can be these two because these ones expand this number, this whole expression. I need a power that's going to compress it down to 3. So I can eliminate these two because they're going to make it bigger than 3. Alright? So what on earth am I talking about? If you look at a calculator, 27 to the third is a big number, which doesn't work, too big, and then 27 to the 9th is also too big. Alright, so let's try the other ones. What if we have 27 to the 1 over 9? What is that? 27 to 1 over 9 is 1.4. I'm looking for 3. Let's try 27 to the 1/3. 27 to the 1/3 is 3. So that's what we're looking for, okay? So just by plugging in and checking, we can see that our answer is 3, okay? If you wanted to do it the long way, you can do it like this. You can just go, let's see, take log base 3 of both sides. So basically, basically trying to express this as a power of 3, right? So you know that 3 to the 3rd is 27, right? So you can write this as 3 equals 3 to the 3x. This is doing it the long way, okay? Since there's no power here, the power is 1. So we're going to take log base 3 of both sides. So log base 3 of 3 to the 1 equals log base 3 of 3 to the 3x. So on the left side, this cancels out, and on the right side, this cancels out. So we're just going to have 1 equals 3x. Divide both sides by 3. And our answer, x equals 1/3. So this is doing it the long way. You don't have to do this. You can just plug and chug to get the answer. But if you want to do it the long way, this is exactly how you do it. Okay, so 2 different ways of doing the same problem. Alright, let's move on to another example. Number 3. Number 3, solve by graphing. So you need a graph paper for this. Solve by graphing. Alright, solve by graphing. We're going to solve the system. Squiggly bracket x plus 3y equals -6, and x minus y equals -2. Okay, so let's do that. All right, let me just label them just for the sake of organization. Call this 1. Call this 2. Let's start with equation 1. So from equation 1, we have x plus 3y equals -6. So I need to put this in the y equals mx plus b form so I can graph it. Okay, so to do that here, I need to subtract x from both sides and divide by 3. Okay, so subtract x. So that yields 3y equals -x minus 6. And then divide by 3. Divide this by 3. Divide this by 3. Divide that by 3. That gives me y. Gives me y equals negative. I can write as 1 over 3x minus 6 over 3 is 2. Okay? So from this one, I know that m is negative 1 over 3, which means I'm going to go down 1 and over 3, starting from where? b, which is -2. Alright? Okay. Now, yeah, let's go ahead and graph that on the side, so we don't lose track of our work. Let's go ahead and graph it. So basically, we start from, this is my y-axis, this is my y-axis, this is my x-axis. So starting from the b, that's known as the y-intercept, you're going to go, so starting from -2, mark a point, you're going to go down 1 over 1, 2, 3. Okay, down 1 over 1, 2, 3, then go up 1, back 1, 2, 3. So you see how all those points right there, okay? So let's make a line, connecting the dots. That's line number 1. So we're going to apply the same process to generate line number 2, okay? So for line number 2, we have x minus y equals -2. So for this one to get y by itself, we subtract x and divide by -1. So subtract x. So we're going to have -y equals -x minus 2. Divide both sides by what? To get y by itself, divide both sides by -1. Everything by -1. And then you're going to have y equals x plus 2. Because minus of a minus slash and dash is plus, minus of a minus slash and dash is plus. Okay? So for this one, m is going to be 1 over 1, which means you're going to rise 1 and run 1, and b is 2, which is what you start on y-axis. Okay? So starting from 2, oh gosh, why did I go that high? This is 2 right here, 1, 2. You can go up 1 over 1. We go down 1 dot 1, down 1 dot 1, down 1 dot 1 right there. You see the line? That's the line that defines the points that define the line. Okay? So you draw a 2 there like that. And basically, the intersection is your solution. Where do they intersect? Right here, right? So there goes the intersection. Region that defines your solution. So what are the coordinates there? For the y, for the x, sorry, we go up, so that it goes 1, 2, 3, -3, and then for the y you go down, -1. So your answer is -3, -1. Okay, so solution to this, solution is -3, -1. End of story. Alright, so there you have it. Now let's move on to another example. This one's a little bit shorter. Number 4. What is x to the -3 over 4 in radical form? So for this one, what does this mean? X to the -3 over 4. The top is the power, and the bottom is the root. What does this minus mean? This minus means reciprocate. Reciprocate. Okay? Reciprocate or send it downstairs. Alright? So let's apply that to this expression. So when we reciprocate this expression because of this minus, it becomes 1 over x to the 3/4. Okay? Now how do you express this as a power and that as a root? This is simply going to be 1 over the 4th root of x to the 3rd. Okay? So the one on the top is the power, and then the one on the bottom is the root. So there goes your final answer in radical form. Alright? Okay. Let's move on to another example. Example number 5. What is log base 7 of 33 in base 5 form? Alright, so what is this in base 5 form? When you're changing bases, all you just have to remember is that the bigger one is the top, the smaller one is the bottom, and guess what? Your base is simply your base. Okay? So what on earth does that mean? It means that log base 7 of 33 equals, on the top you're going to have log 33, because that's what's up there, the big one. The base, the small one here, goes on the bottom, log base 7. And guess what? The base that you're converting it to is 5. So just put a little 5 here, and a little 5 here, and that's it. Okay? So that's basically the change of base formula for you. So if you're going to a target base, make that the bases. The big one goes on top, the space goes on the bottom, and our story. Alright? Okay, let's move along to number 6. Number 6 involves the history of logarithms. So if log base 2 is approximately um, 0.3010, and log base 3 is approximately 0.4771. What is log 36? What is it? So to do that, all we just have to do is express 36 using 2 and 3. How do I know what 36 is using 2 and 3? I'll just break it down, right? So write down 36 and break it down using 2 and 3. So if I take out 2 from 36, I have 18. It's even, so I can take out another 2. That leaves me with 9. And then I can break down 9 into what? What goes into 9? 3 and 3, right? 3 and 3. Okay? So log base 36 is the same thing as log. This is log of 36. Log of 2 times 2 times 3 times 3. Now what is plus? I mean, what is times in the log world? Times in the log world, remember, times in the log world is addition. That's what logarithms was created for, to make multiplication addition, okay? So if I change this whole product region here into log form, guess what? This is going to become log base 2, log of 2 plus log of 2 plus log of 3 plus log of 3. Okay? So it's going to be 0.301 plus 0.301, or I can write 2 times 301, same thing, plus 0.4771 plus 0.4771. Okay? So you're going to need a calculator for this exam so that you do well on it. So I don't want to waste time, so I'm going to write 2 times 0.301 plus 2 times 0.4771. You can write it like this if you want. Bam, answer is 1.5562. So the answer is an approximate answer, 1.5562. Okay? So all you just have to do is break down the number using the bases that you know and change it from times to addition or whatever, and then make the substitution, and that gives you the results that you desire. Alright? Okay. Now let's move along to another example. Clear the page. Number 7. Number 7 is a probability question. Okay? It says an urn contains 4 red, 3 white, and 5 green marbles. What is the probability? What is the probability of picking a red and then a green with A, no replacement, and B, with replacement? Okay? Alright, so let's do this. So for the A part, there is no replacement. That means it's independent. I'm sorry, that means it's dependent. Since there's no replacement, it changes, right? The total amount changes. So for if you want to pick one red, you're going to say how many reds are there over the total. Okay, for the red. So how many reds are there? There are 4 reds. 4 reds out of how many balls you have in all? 4 plus 3, 7 plus 5, 12. So this is success. 1 out of 4, 4. And then over the total is going to be 12. Okay? Times. We'll now hope to get a green. How many greens are there? 5 greens. But wait, since there is no replacement, did the total go down? Of course. Since there's no replacement, that means 1 is gone, you're left with 11. Okay? The answer in this case is going to be 20 divided by 132. Okay? How about with replacement? If it's replacement, it makes it independent, which means it doesn't change. Okay? So what's the probability of getting a red? It's 4, because there are 4 reds out of how many in all? 4 plus 3 plus 5, 12. Times. Now that one red you took out, guess what? You tossed it back in. Probability of getting a green, 5, because there are 5 greens. Now, how many balls you have left? Since there is replacement, it doesn't change. The bottom doesn't change. So this becomes 20 over 144. And we can reduce that into 5 over 36. We can divide 4 goes into both of them. If I divide this by 4, divide this by 4, and divide that by 4, I'm going to end up with 5 over 36. And there goes your answer. Okay? Alright. Now the last problem we're going to do, number 8. Number 8, it says, what is the first 3 terms? I'm sorry. Let me see what are. My bad. So what are the first 3 terms? What are the first 3 terms in the expansion of x minus 3y to the 4th? What are the first 3 terms? So to do this, we need to go to Pascal's triangle row number 4, starting from 0. This is row 0. So you're going to go 1, 1, 1, 2, 1. This is row 2. 1, 3, 3, 1. This is row 3. 1, 4, 6, 4, 1. This is row number 4. That is what I want. So let's line it up. 1, 4, 6, 4, 1. I need only the first 3 terms, right? So I just need to expand these. But let me set up the whole thing. So it's going to be x to the 4th, negative 3y to the 0, x to the x to the 3, negative 3y to the 1st. You see how this power is going down, this one is going up. X to the 2nd, negative 3y to the 2nd. Do I need to continue? No, because I just need the first 3, right? But you can do the rest if you want. All that we need is just the first 3. Remember, the powers have to add up to 4. So let's expand this, and that will be that. All right. So negative anything to the 0 is 1. So this one becomes 1, and you're left with x to the 4th. This one is going to become 4 times x to the 3rd times this minus. Does the minus come out? Since this is an odd power, the minus comes to the front, times 3. So this is negative, oh, there's some more here. Negative 12 x to the 3rd y. And then the last one is going to be 6 times x squared times, since it's negative to an even, that goes away, times 3 squared y squared. The even power killed up the minus, okay? 3 squared is 9, 9 times 6 is 54. 54x squared, y squared. So your first three terms are going to be x to the fourth, scroll down a little bit, minus 12x to the third y, plus 54x squared, y squared. Okay? Alright, good job paying attention to this presentation. Remember, it's uploaded on YouTube for your viewing pleasure. Alright?